Source control or version control is the practice of tracking and managing changes to the code. In this video, we will be covering what is source control, benefits and best practices of source control, types of source control, centralized, distributed, and difference between Git and TFVC. Please check the description below for more information. In the end, we will also share details about a free Azure DevOps Engineer Masterclass, which will not only help you understand basics, but it will also give you an idea of the learning path to follow. It would be helpful, especially when you're preparing for Azure DevOps certification, that designing and implementing Microsoft DevOps solution 𝐒𝐴𝐧 400, which will earn you DevOps Engineer Expert certification. As a prerequisite of this certification, one should be certified Azure Administrator or Azure Developer. Welcome to another episode of Azure video series from K21Academy, where we take you from complete beginner, covering integrate logging and monitoring, to all the way defining and implementing a continuous delivery and release management strategy, including continuous integration, source control, and security, as well as how to prepare for the Microsoft Azure DevOps Engineer certification. We have taken a clip from one of our certification training program on designing and implementing Microsoft DevOps solution. That's 𝐒𝐴𝐧 400. And in this clip, our Microsoft certified trainer will talk about source control. So, this is a clip taken from a module on implementing DevOps development process. Now, let's hear from our expert trainer on the same.
So in this module, we will be seeing about getting started with source control. So as we discussed previously, there are multiple sections with multiple modules and multiple lessons. So let us go one by one. The first lesson that we are going to see in the module 1 is going to be what is source control. So why do you think we need a source control? What is the use of source control? So in a DevOps, the main use of source control is nothing but to save your code or to make sure your code is being having a version, so that if you wanted to track down what are all the list of releases that went previously, you can easily do it. Or if you wanted to revoke back to the previous version, it will be useful if you have a source control in place. So in DevOps is a revolutionary way of releasing software quickly and efficiently, maintaining a high level of security. And in this complete life cycle, like which is code, build, test, release, deploy, operate, maintenance, and planning and everything. So for this, the main part is a source control, because all these things you can save it in your particular file and you can version control it accordingly to each and every changes that you're going to make. And what are all the foundational practices of DevOps? So if you see, there are mainly two sections out of it, which is defining your practices and practices that contribute to success. Stage 0 is nothing but it is just trying to define a practice like monitoring. You have to do a monitoring, you have to do a lot of deployment patterns, you have to write a testing patterns and contributions and everything. But actually nothing is there to contribute to the success, because you are just doing a planning out of it. Stage 1 is nothing but the application team is mainly using a version control system. With that, what you can do, you can actually build a standard on set of technologies. You can put application configurations in a version control system. You can test the infrastructural changes before it goes to the production, and you can even do a source control available to the other teams as well. Stage 2 is nothing but building is a standard set of technology. The first stage is stage 0 is planning, stage 1 is coding, stage 2 is building. And again, on the building, what are the practices that contributes to success? We are going to use a source control system. Why? Because the building codes and artifacts that you're going to create after the build, you need to again do a source control out of it. Stage 3 is going to be a manual approvals and deployment patterns and everything. Because we have done a CI, the next is going to be CD. Okay, either you can do a manual approvals, or either you can do an automated approvals, or infrastructure deployment patterns and anything you can do. And again, you can use a source control in this as well, because as I told you, the complete infrastructure and everything can be written as a code, and that code can be maintained as part of your version control as well. And stage 4 is going to be provisioning. So application configurations are stored in a version control system, and infrastructure configurations are also stored in a version control system. And stage 5 is going to be a monitoring. So incident responses and everything can be automated and other things. If needed, we can also use a version control on this in incident configurations as well. So we can actually download the entire CMDB, which is change management database, and then we can upload it as part of your version control as well. So basically version control is a key part of DevOps, and this particular stage tells you like each and every stage I can use a version control to help my contribution towards success. And what is a version control system? As we discussed about, it is mainly used for practice of tracking and managing the changes to the code. We need to find out who has changed to the code and when it has been changed and what is the previous version, what is the next version, and that is the main use of your version control system. And it provides running history of code development and helps to resolve conflicts when merging contributions. So what is a conflict? Conflict is nothing but when a user, so if you consider for example you are a user A and there is a user B, if both the users are actually working on the same code and same line, while you try to save a code, there will be a conflict occurs, because when both the people are trying to change something on the same line, how do a tool accept it? Tool will not accept, tool will get confused. At that time there will be a conflict happening. So you can help to resolve, or you can clear the conflicts by actually talking to both the developers, like okay, I can keep my code, you can revoke it, or you can keep your code, I can revoke it. So that's how you can resolve your merge conflicts. And it also protects the source code from both catastrophes and casual degradation of human errors, which means if you're making any mistakes also, you can easily recover back if you actually have a practice of source control system. Okay, and what are all the benefits included? As I told you, reusability is one of the main thing. Traceability, who has done mistake in which area, what time, and other things, you can find it out from the logs. Manageability, because you can easily manage your entire DevOps lifecycle in this source control. Efficiency, it's very much efficient and easy to use. And collaboration, because multiple teams are using the source control system, so there will be a lot of collaboration between multiple teams. And learning, so you can learn a lot of things like both the command line and the graphical user interface, and how do you integrate the source control as part of your CI/CD. So there are a lot of learnings also coming into the place. Okay, so this is on a nutshell about what is source control. So we will see in next lesson like what are all the benefits of source control. Until then, thank you. So in this lesson we will be learning what are all the benefits of source control. So what do you think is a benefit of a source control? As I was telling you, source control is going to be used throughout your DevOps lifecycle, and it helps us to save the code, maintain the history, reusability, traceability, everything is there as part of your source control. So what do you think is a benefit out of it? So benefit is like you can create multiple workflows. Okay, you can create a separate workflow for a development, you can create a separate workflow for a production, you can create a separate workflow for a testing as well. And you can work with multiple versions, and as I said, many people are going to use the same version control system. So it is not like only your team is going to use it. If you're actually using a Git version control, or if you're using a TFS version control, then it is going to be used by your entire organization. So there has to be a lot of collaborations that you need to do with multiple teams. And you can maintain a history of versions, like you can see last 5 years, 10 years of data even be stored on part of your version control system. And the main advantage is like you can automate as much task as you can, because that is the main use of the source control system. And what are all the best practices that you need to follow as part of your source control? So always try to make small changes, because small changes are easily traceable and easily revocable as well. And don't use to commit a personal files like your ID cards or like your passwords and other things. It is mainly professional and it is mainly used for your coding, not to save your personal data. And update very often and right before pushing to avoid merge conflicts, because as I was telling you, if both the users are actually working on a same program, there will be a lot of possibilities like there are merge conflicts occurring. Instead of that, try to actually update as soon as possible or as much as possible, so that you're avoiding the merge conflicts, and it is actually helping you to save a lot of time as well. And always verify your code changes before pushing it to a repository, because you need to make sure like whether you have missed something, or because when you try to push something to the code repository, your existing code should not get breaked up. So you should always try to check your existing codes, or you should always try to verify your codes before you push it. And always pay close attention to your commit messages, because commit messages are one of the main thing which helps you to clearly identify why have you pushed the code. Because if you just say test 1 2 3, then your management or your auditing people will not even know why have you pushed this code. So commit message is mainly important. And if possible, try to link your codes with the work items. Work items are nothing but your tickets. Like for example, if your managers or someone is actually assigning you a ticket to create a development branches, or to actually they have assigned you a particular feature to work on, so try to give that ticket number along with the commit ID, so that when they reference the ticket number, it will be easy for others to identify who has given you the task and when was this task given. A lot of things can be easily identified. And whatever your background or preferences is, always be a team player and follow agreed conventions and workflows. Okay, even if you're an individual contributor, or if you're a tester, or if you're a manager, or even if you're a senior manager, always follow the standards. It's not like if you're a different individual you have to follow different standards. No, there are certain standards as per Git and certain workflows as per Git, so you have to always follow that, no matter whatever background you're in, or no matter whatever the designations you are in, because you are going to follow the standards not for you, you're going to follow the standards for the benefit of the company and organization. So always follow the standards and always follow the workflows. Okay, so these are all the main benefits of source control system and the best practices of source control system. So in our upcoming lessons, we will be seeing what are all the different types of source control systems and much more. Welcome back. So in this lesson, we will be seeing about what are all the types of source control systems available in the market. Generally, there are two types of version control systems available. One is centralized version control system. Another one is like decentralized or distributed version control system. So what is centralized version control system and what are all the strengths of it? We will see it. So as the name indicates, it is centralized, which means there will be a common server available and there will be multiple clients available. Okay, so it can easily scale for very large code bases, and it has a granular permission controls. It can permit monitoring of any usage, and it allows file locking and everything. And it can be used for integrated code bases and audits and trials and hard to merge file types. And this is mainly old kind of version control system, which you can see, like if a common server goes down, then the connectivity between the client and the server will be lost and people will not be able to recover that data. So it is a traditionally old one. So here you will see subversion, CVS, PVCS, TFS version control system. So all these are actually falling under this centralized version control system. And the new one or the updated one is a distributed or decentralized version control system, which means you can see there is again a common server and there are multiple clients. But what happens if a common server goes down or in unavailable, then the client itself acts as a server, and there will always be a connectivity between the client and the server, so that your data is not getting lost and people around the world will be able to use it without any intervention. And the strength of it is like it is cross-platform support, which means you can use it in any OS and you can use it in any mechanism as well. And it is open source and absolutely free. And it provides, as I told you, it provides an offline support as well. So you don't need to necessarily connect to internet. You can even work from your offline. And it has a huge history collections, and it is a fast growing now in an industry. And it is mainly used for small and modular code bases, and you can actually use it for highly distributed teams across the world, and mainly used for greenfield code bases. What do you mean by greenfield? Is nothing but a project which is going to start from the scratch. It's going to be a greenfield project. Okay, and what happens here is like every developer actually clones the master database into their system, and then even if the net connection is not there, they can still work offline. Okay, and the main advantages or main examples of this distributed version control system is our obviously Git, GitHub, Bitbucket, Mercurial, GitLab, Azure repos. All these are part of this distributed version control system. Now, our main focus on this exam would be Git and TFS version control system, which is Team Foundation version control system. What is Git? Git is nothing but it is a distributed version control system, and each developer has a copy of repository in their development machine. And what is TFS version control system? It's a centralized, as we have seen it in an example. And team members have only one version of each file in their machine. They, as I told you, it is server dependent, and if the server connectivity is gone, you will not be able to get all the data. So in the server workspace model, before making any changes, team members publicly check out the files. And in the local workspace model, each member takes a copy of the latest versions of the code base and work offline as needed. If you see the Google trend, actually, the distributed version control system was actually down, and it has become very famous in the recent trend. Whereas during 7-8 years back in 2010 11's centralized version control system was at the peak, and now it has gone to the lowest level, and none of the other companies in the world is actually using a centralized version control system. And that is the reason Microsoft even acquired Git and GitHub, and that is the reason like Git has become #1 tool across the world. Okay, and we'll see why are we using Git. Why? Because as I was telling you about, the main thing is like it is a distributed version control system, and it is very easy to use. It is a open source, and it is a cross-platform dependent. And apart from that, what are all the other things that we use on Git? It is very used to create a feature branches in the sense like, for example, if multiple teams are working on a single project and multiple features are being developed, it is very easy for them to use a Git, because they can easily create a feature branches from the master branch, and they can work on, whenever the work is done, they can merge their branches back to the master. And distributed development is very easy over here, and they can take a full repository clone in each and every one's machine, and without anyone's intervention or without any dependency, they can work. And pull request is nothing but a merge. So as I was telling you about, once if the feature is completed, they can raise a pull request to the master, and once if everything is completed, then they can merge the changes to the master, and it goes to the production. And Git has a variety of community. Like, you can go to the GitHub communities, and whatever questions you have, you can post it there, and you can get a multiple replies from the community people around the world. And it is mainly used for a lot of release cycles, because as I was telling you about, you can create multiple products with multiple branches, and you can easily release it to the customers, and you can even collect it as a feedbacks and store it on a version control system. So a lot of advantages are there on Git, and that is the reason Azure DevOps mainly uses Git. And it doesn't mean like Azure DevOps actually uses Git. Azure DevOps has two options for you. So they will give you both the distributed version control system and the centralized version control system. So whichever you wanted to use, you can still use it. And what are all the common objections of the Git? So Git generally allows you to overwrite the history, but TFS version control system does not allow you to do that. And for the large scale objects, Git is best useful for it, and whereas for TFS version control system, like, it doesn't allow you to store very large objects at all. And Git, you can have a large repositories as well. There is no blocker for it. And what is the difference between Git and GitHub? It's nothing but Git is your local and GitHub is your cloud, or you can call it as your GitHub is your public server available all over the world in a cloud machine. Git is going to be your local software or local client that you need to install it on your machine. And what is a learning curve? Learning curve is nothing but, see, initially people will face some issues in learning Git and GitHub and commands and other things, but with some trainings and instructions, it will be very much helpful, and it will be very much doable as part of all the areas across.
So, that was a clip taken from one of the lessons from our step-by-step training program, Microsoft Azure DevOps Engineer, AZ400. I would like to invite you for a free 90-minute session with our Microsoft Certified Expert Trainer, where we talk about the Azure DevOps Engineer training and share information about getting certified by using our step-by-step roadmap to go from complete beginner to a certified Azure DevOps Engineer. If you're interested, register for a free class by going on to K21Academy.com/AZ40002. Additionally, we will show live demo of blue-green deployment with Azure App Service. We will also share information about the certification exam. So, you can register for free by going on to this URL, K21Academy.com/AZ40002. I will see you in another episode of Azure video series from K21 Academy. Till then, take care.